For this lesson for today, we're going to be going over some calculator fundamentals for the Casio fx-115ES Plus. Now, this particular tutorial is just going to show you fundamentals as far as how to navigate through your calculator, as well as to set it up. So let's jump right in. The first thing we're going to do is just to go ahead and set up your calculator into common formats you're going to be using for your exams. Now, the first thing we're going to be going over is to set up your calculator in natural display, which means you're going to be using Shift, Mode, and they're going to be using option 1, and then option 2, which is line output. Now the reason being you do this is, for example, let's go over 1 divided by 2. When you do this, it shows you in a line output. If you were actually to use the math IO output, so we'll do the same thing again, but I'll choose option 1, it's going to give it to you in a fraction form. And usually we want to just go ahead and a line output form. That's what we're used to seeing. So we're going to go ahead and set that back up and use that format. You can use whichever one you like. I'm just setting up the calculator in most common ways that's used on some of your practice problems themselves or some of the videos. Also to keep in mind, this particular function is only available on the Plus. If you have the older model, just the 115ES, option 2 right here is not available. Since that's not available, you're going to have to actually choose, if you have the older model, you're going to have to choose option 2. Next, we're going to set up for degrees, which means we're going to use Shift Mode, and then option 3, which is degrees. Because most of our formats, especially when you're doing complex calculations, you're going to want it in degrees, especially when you use it in polar form, as well as converting back to rectangular form. Next, we're going to go ahead and set up for exponential format, which means it's going to be Shift Mode, and then 8, and then option 1. Now, you're probably wondering, why do you do this? Format will help determine your engineering notations, or this will actually help you when actually solving some of your problems. Let me show you. Let's go ahead and see what an output would look like with 1 divided by 800. Well, right now, that's an engineering notations, 1.25, and that's going to be milli. If you chose option 2, so let me go do the same thing, 8, option 2, the answer is going to be laid out with as many zeros as it needs to be to show you what the answer is. Instead of giving it in engineering notations, it's going to show you the answer with all the leading zeros, which can be very hard or can be confusing sometimes, because if you have to sit there and count all the zeros, that's just time wasted and you have a chance of having a human error. We're going to go ahead and keep it in exponential format. So we're going to choose option 8, option 1. Lastly, and this part is kind of optional, but I went ahead and show you how to set up anyway. It's going to be Shift Mode, and then we're going to go down 1, and then we're going to click on number 3, which is complex format. I'm going to go ahead and choose the rectangular format just because that's a personal preference. If you like, you can keep it in polar form. I'm just going to keep it in rectangular form. So with these particular options, this should at least set your calculator up for a majority of your engineering problems. All right, let's jump into the complex mode. All right, now let's go over complex mode. Complex mode is very simple. You click Mode, and then the number 2 for complex. And what this does is put your calculator in the complex mode. Now what this also does is it unlocks a few features. One, your minus sign right here, or your negative sign, now it actually unlocks that feature right there, which is your angle. And it also unlocks, right here where it says your engineering notation, unlocks your actual imaginary unit, which is I. So let's do a quick example. Let's just say you want to do 2 plus 5, and right now, since you have it in complex mode, when you hit engineering notation, it now gives you imaginary unit of I. And then obviously you hit equal, it goes down here. Now let's just say I want to try a polar version. I could say, and this is not going to be the same answer, but I just want to show it to you. It's going to be Shift, and then your negative symbol, which is going to give you angle. And I want to come up with something random. We'll say 90 degrees. And it's going to be 2I. Now earlier, if you remember, we actually put this in rectangular format. So it's going to be in rectangular form right now. So if you want to actually convert this to a polar form, I can go Shift, and now this is unlocked, which is complex 2, and you can convert it to rectangular or polar format. So I want to hit number 3 for polar format, so it's going to take my answer and convert it to polar format. Hit enter, and then 2 at an angle of 90 degrees. So this is just to get your feet wet on the complex mode. It's very common to see this used in most of your engineering problems. Let's go ahead and move on to the next section, which is your base units. Now let's go over the base N mode. Base N mode lets you actually perform calculations and conversions in several different base unit forms, such as decimal, hexadecimal, binary, and octal. So let's jump in and go change our mode to base N mode. So it's going to be mode, and then option 4, which is base N. So now we're in base N mode. Right now it's showing it in decimal form. So let me go ahead and pull an example out from one of our previous videos. In one of our videos, the microcontroller video, we actually performed a calculation when we're in hexadecimal format and we want to go to binary. So let me go ahead and put in hexadecimal. Hexadecimal is going to be right here. If you look right above these 4 buttons, you'll see decimal, hexadecimal, binary, and octal. So I want to go ahead and put in hexadecimal. Now on that problem, we had it to where it said 3D. So I'm going to have 3 right here. And then also you'll see these letters unlocked. You'll see A, B, C, D, E, and F. So I'm going to go ahead and say D, hit enter. So now 3D is actually down here in your hexadecimal format, which is what we want. And we want to convert this to binary. So all we have to do is leave it right here and actually click on binary. And it actually converted 3D into a binary output. Well, let's just say we'll leave it in binary and go 10001 plus, we'll just come up with some other random numbers. It'll actually add those two together for you and keep it in that same format. Not only can you do the add and subtract, but also you have and OR gates. The way you use that is you use the unlock function of shift 3, and if you see right there it says base, and you're going to see AND functions, OR functions, negatives and nots, and exclusive ORs, and so on. So if you actually want to perform some calculations just with your calculator by using gates, this function is available. Let's go on to the next one, which is matrix mode. All right, now let's jump into matrix mode. Matrix mode allows you to go ahead and input several of your calculations in a matrix format. Let's go ahead and try one out. Let's go ahead and put you in matrix mode first. So it's going to be mode, and then option 6, which is matrix. And then it gives you the option of what matrix you want to start with. So we're going to start with matrix 1, which is matrix A. And now I want to go ahead and do an example from one of our other videos. I'm going to go ahead and go through the mesh analysis video and pull that example out. So I'm going to say we're going to need a 2x2 matrix, which is going to be option 5. And then I'm going to go ahead and plug the same numbers we had in that video. So we had 15, then I had -10, -10, and then 45, and then hit enter. And that's going to save that matrix with these particular numbers in there. So I'm going to hit AC, which gets us out of that. And now I'm going to do the same thing again. I'm going to go back to mode, matrix 6, and then I'm going to say matrix B, so option 2. But for this one, I want to go ahead and say I want a 2x1. So I'm going to click option 6, and I'm going to put the same answers I had in that one, which is 100, and then I had 0. And then I'm going to click AC again. So right now I have matrix A and matrix B saved in my calculator. So now we have this other feature that's unlocked down here, which is your shift 4, which is your matrix. So it's shift 4, and it lets us perform calculations with those two matrix inputs we put in there. So I'm going to say option 3, which is matrix 1, that was that 2x2 matrix. And what I'm going to do is I'm going to go ahead and invert it. And then I'm going to say times, and then same thing, shift 4, and then I'm going to select my option B matrix, number 4, and then click enter. And then it gave me the exact same answers I've gotten in my previous example for that video. So 7.82, and you click down and it'll give you the next one. Another option this calculator has, when you go to shift 4 for matrix, you also can find your determinant for matrix as well, and various other things. So I'll do an example. So if I want to find a determinant for that same matrix, matrix A, it's very easy. Just plug it right in there, and it'll give you the output of its determinant. So this calculator is very powerful when it comes to actually solving matrix functions. However, it's maxed out when it comes to 3x3 matrices. Plus, it has a hard time processing complex format in matrices mode. So just keep that in mind. All right, let's go on to the next section. Now let's jump into equation mode. Equation mode I actually found very helpful actually over the matrix mode, because I actually use equation mode instead of my matrix mode in most of my videos because it's faster, quicker, and it's just much cleaner. So let's show you how to use it. So you're going to use mode, and you're going to click number 5 for equation. Now if you look at this, it actually has several different options you can choose from. I went ahead and I'm going to go say we're going to use option 1 for that last example, because this is going to give me the same answer as I actually desire when I'm performing that matrix mode. It's just going to be quicker. So let's do option 1, and it already provides me a matrix right here. So I'm going to go ahead and put those same calculations in there. So it's going to be 15, and I'll hit enter, then -10, and then my second matrix had 100 right here, so we'll go ahead and plug that in there. And then down here we had -10 again, and then 45, and then we had 0. Now if you look at this, consider this right here my 2x2 matrix, and this is my 2x1 matrix. It just went ahead and put it in the equation format, so it made it really clean and easy. And all you do after that is hit enter. And if you look at it, it gave me the exact same answers. Hit the down arrow for the next one, same exact answer. It was just a lot quicker and cleaner. So right now I just want to show you this mode just to help things along and save you time when you're doing some of your practice problems or some of your exam problems. All right, let's jump into the next section. All right, the next item I want to go over is the integration function. Now this may be self-explanatory to some of you who are very good in calculus. However, I want to show you little hints and tricks as well as a few potholes that you're going to see with your calculator when using this function. First of all, this function only can be used in math input-output mode. So when you go shift mode, it must be option 1, which we already set up at the beginning. However, if you have option 2, it will not actually work correctly. So I want to go ahead and put it back into shift mode, option 1, and then I'm going to go ahead and choose one of these two, and I like line mode, so I'm going to choose option 2. So now, if you look at it, it actually gives you into the format you're used to seeing. So just keep that in mind. That's also true when performing log function. Look at log, I have log and it's filled out correctly. So I can put log of 2 right here and put whatever else I want in there. So let's just say I actually went back to line mode, same thing. It would not give you the format that you'd like. So just keep that in mind. You have to keep this in math input-output mode, and then one of these two, which I always say line output. Okay? So just keep that in mind. That's a little disclaimer you need to know when performing this function. So let's go ahead and do an example real quick. So I'm going to go to my digital modulation video, and I'm going to pull out the equation from that video. So I'm going to say, we're looking for the integration. I went ahead and picked the equation right out of that video. I'm going to say Shift E. We're going to say negative, and this should be X. And that's going to be square divided by 2. And then we're going to go use the arrow, do parentheses, and that's going to be 1 divided by, and this is going to be the square root of 2. And then I'm going to want pi, so it's going to be Shift pi, move out, close parentheses, and then I want to fill in these two guys. Now in the video, I actually showed you where you can't put infinity in here. Instead, I put 1.4142, and up here I picked a random number. Now this one I went as high as 100. So I just picked a random number, but I made it high enough to where it wouldn't actually conflict with my answer. And then I hit enter, and you wait. And then gave me the exact same answer as I used in the video. So that worked out perfectly. And it's very quick and easy to do this integration using this calculator. Now, you see how fast mine went when using the calculation? Some of yours, it's going to take a lot longer. Mine took, I believe, up to 15 seconds when I did it on my hand calculator. So just keep that in mind. It didn't freeze up, it's just processing. So I know this is actually a very simple function. However, I want to go over the potholes. That way, when you're actually trying to use that function and it's not working, it's to show you why or why not. All right? Let's go into the next function. All right, the next actually nifty feature this calculator has is the constant feature. The constant feature actually provides quite a few different constants for any of your various calculations. And you can actually find these constants either in your Casio manual, or you can look on your shell or your casing of your Casio, and you'll see a list of them. And it goes through 1 through 40. And the way you actually input this in here is you go ahead and click on Shift 7, because constant, if you look right above the 7, you see constant, and then you pick which constant you want. So let's do an example real quick. I want to go through one of my videos. In my permeability video, I actually used a magnetic constant. So that's going to be option 33. Click on 33, and then right there I have my magnetic constant. Now what I did in the video is I went ahead and plugged the whole thing out. But if you want to save yourself time, and actually if you practice with these constants, you can get a lot quicker and actually get a more accurate answer. So in the video, I did my magnetic constant times 100, and then enter. And that gave me an answer of 1.25 or 1.26 times 10 to the negative 4. So this right here gave me the same answer as what I used in the video. And again, there's other constants that are useful when doing some of your engineering calculations. I went ahead and listed a few helpful ones that I've noticed in some of my videos, such as the speed of light in a vacuum, the electric constant, characteristics of impedance of a vacuum, and so on. Now, there's other ones you can use, but these are some of the ones I use in some of my videos. Remember, it's on the back of your case, so you're not cheating. All you're doing is looking on the back to reference which constant's available. All right, let's go to the next feature, which is our conversion feature. All right, for our next feature, we have our conversion feature. Similar to the constant feature, however, it just allows you to take one unit and convert it to another one. Now, in one of our videos, our electromagnetic wave video, we actually converted miles to kilometers. So let me go ahead and do that same example. So we're going to use shift, and then if you look 8 right here, you see right above 8 it says conversion. And now if you look on the back of your casing, same just like constants, you'll see at the very bottom of your casing, you'll see a list of unit conversions. And I want to go ahead and convert miles to kilometers. So if you look on your casing, it's going to be option 7. So it's going to be 0, 7. And then it's going to be miles to kilometers. Now in that example, I believe I had 1,000 miles, and I want to go to kilometers. So I hit enter, and it went ahead and took and gave me 1,609.344 kilometers and 1,000 miles, which is correct. It's the same answer we had in the video. Now again, you can use this various different ways in any format you need to. The common ones I see is either in length, such as miles to kilometers or vice versa, or I usually see it in temperatures. Some practice problems have some of your temperatures in Fahrenheit or Celsius. If you wish to go ahead and convert Fahrenheit into Celsius, same thing. Like if I want to take 98 degrees and convert it, so we're going to say shift 8, option 37, and it's convert my 98 degrees Fahrenheit to Celsius, and it gives me 36.66 repeating of Celsius. So not all of your problems are going to have the same unit types. You might have to convert it to that. All right, let's go into the last function, which I believe I saved the best for last. For this slide, I think I saved the best for last. It's going to be the solve function. Now the solve function, it actually could save you a very, very long time. And in fact, I don't use it in most of my videos because I want to actually show you how to break down the math and use your algebra to go ahead and find an answer. However, if I use this function in the majority of my videos, it might actually cut some of them in half. I'll give you an example. Let's jump right in and look at the Shannon-Hartley theorem. And I'm going to pull out an equation I use, and I broke it down throughout like half of a video or half an example. And you actually can see how I did the algebra and broke it down. However, if I use this one solve function, it would have just cut the time greatly. So let me go ahead and plug in the initial equation, and we'll see how we can do this. So if you look on that video, it says 10 megabits equals, and what I'm going to do is I'm going to do alpha, and then you see the equal sign right there, equals. And I'm going to do the same thing. I'm going to finish out the equation, 2.4 megahertz, so it's 10 to the 6, and then it's going to be times, and it's going to be log of 2, and this is where you got to make sure you get your parentheses right. So I'm going to say 1 plus, and do another parentheses because you never have too many. Now for this one, I have signal, which is S. I can use X or Y. I'm going to go ahead and use X. That's just the one I prefer to use. So I'm going to say alpha X. That's going to be my signal in this case. And I'm going to say divided by 4.8, and this is going to be milliwatts, so it's 10 to negative 3. And I'm going to close that one out, and then close out the 1 plus the same thing. So right now, I just plugged in that whole equation in this one bit of the calculator. Now, all I have to do is make sure you don't hit enter, because most time your muscle memory goes to enter. Don't click on that. Click on shift, and then solve. And then hit, now you go ahead and hit enter. And it's gave me the exact same answers I had in the video. In the video, we had 81.02 milliwatts. Well, I have the same, very similar answer here too. I have 81.40 milliwatts, which is actually really close. The only reason it's probably more accurate because I plugged in the calculator in this way. So in the video, I'm sure I rounded up when doing some of my calculations, whereas this one, it gave me a more accurate answer. It's still very similar, but it's actually a lot accurate and a lot quicker. So keep in mind, this is actually a very nice function to have. You can put in very long equations and go ahead and get the output you need just by putting the variable you're missing. Keep in mind, this is not an all-powerful function. It doesn't always work. At some calculations it cannot perform. So I wouldn't hang your hat on this particular function. However, if you actually feel confident and you want to save time, by all means use it. I want to go to one last slide, and this is more of a bonus slide. All right, now for our last slide, I just have a few bonus features I just want to go over. In some of my videos, you may have seen me use this one button right here. It actually converts your either decimal to fraction form or vice versa. So you might actually see me do this, and then in some of my videos, I didn't set up my calculator before I started the example. So some of my answers may be in fraction form, and then you'll see me click on this one little button right here, and it'll convert it to decimal form. Very helpful feature to use when doing your calculations sometimes. Sometimes you might want it in a fraction form, sometimes you do not. So just keep in mind you have that button right there that allows you to go and switch between those two forms. And I do it in various videos. The other cool feature we have in this calculator is, especially us being engineers, we have a nice little cool button that actually allows us to take our answer and convert it to engineering notation. So for example, I'm going to take 100,000, make sure I got enough zeros, hit enter, and then if I want to convert this to engineering notations, I'll use this button right here. It says eng, and it converts it to engineering notations. So we have 100 kilo, back to our original answer. Then it goes to milli, and I think that's where we can get to stop at because our calculator can't go any further. So just keep that in mind. If you actually come across some of your answers that are like, for example, 10 to the negative 4, that will put it in engineering notation, but you can go a step further and keep going. So that's in micro, nano, and so on and so forth. So that helps us as engineers when we're trying to go in milli, mega, giga, pico. It actually helps us determine our answers in engineering format so we don't actually have our operator error in the mix. Also, one last thing, when I did a lot of these features and functions, you'll notice at the bottom of these slides, you'll see a little disclaimer, and it tells you your calculator needs to be in general calculations mode. In other words, when you click on mode in option 1, you want to be in that particular mode. Sometimes I do it myself. I leave it in complex mode when doing a lot of my engineering calculations. Well, this will not work when it's not in that format. See, I click on engineering and it actually enables your imaginary unit. So when you go to your modes, just go ahead and leave it on general calculations mode, which is option 1. Because option 1 allows you to do a lot of these features and functions we went over in the previous slides. The only time you should leave it in complex mode is if you know you're doing a complex calculation. Hopefully this is enough information to get your feet wet, and hopefully you can be able to answer a lot of your questions a lot quicker and more efficiently. So if you have any questions, feel free to let me know, and I hope you all have a good day. And one last thing, in the description section below, I'll put a link to the NCEES approved calculator policy. That way you can stay up to date of which calculators you're allowed to use on the PE and FE exam.